Okay, so here's the mark scheme for the Unit 2.2 assessment in December 2023. Okay, question 1. The table shows 4 compounds and their formula. So here we have the compounds, which of course are names. Some of them give you a clue as to what's in them, some of them don't. Here we have the formula using the symbols from the periodic table, okay, which you could look up in the periodic table at the back of the paper if you're not sure. Use information in the table to answer the following questions. Give the name of the compound that contains elements hydrogen and bromine. So, just in case we're not sure, we can look on the back here and we can find that hydrogen has a symbol H and bromine has the symbol Br. Okay, so if you look at our formula here, we're looking for HBr and there it is. We're looking for a name, so that would be hydrogen bromide. So make sure that if you're asked for a name, you give a name. If you're asked for a formula, you give a formula. Okay. The next question asks for the names of the elements present in ethane. Okay, so this is ethane here, and the ethane contains 2 letters. We can ignore the numbers for this question because we're just interested in the elements, C and H. So again, if we turn to the back page where we find the periodic table, if we're not sure, we can find that the letter C is carbon and the letter H, which you've already seen in the previous question, is hydrogen. Okay, so the answer there is carbon and hydrogen. Okay, give the total number of atoms found in the molecule of nitrogen dioxide. So nitrogen dioxide is this formula here. So if we were to draw a diagram of that, we might draw a nitrogen atom. And there's only 1 in the formula because there's no number next to it. But then we'd need to draw 2 oxygens attached to that nitrogen atom because there's a 2 there, meaning 2 oxygens. So in total, we have 3 atoms. Okay, so the total number of atoms is 3. The next question asks us to tick the box next to the diagram that represents the molecule of ammonia, NH3. Okay, now NH3 tells us that we'd have 1 atom of nitrogen and 3 atoms of hydrogen. Okay, so we'll just draw something like that. And so if we look at our little diagram here and compare it with the ones that we've got available to us, then obviously this one here is the nearest fit. So that would be the diagram of ammonia. Final question on this page. Some ants spray a toxic mixture containing formic acid to defend themselves from predators. Each molecule of formic acid contains 2 atoms of hydrogen, 1 atom of carbon, and 2 atoms of oxygen. So if we take this in the order we're given, okay, it says use this information to give the formula of formic acid. So a formula would look something like this with the elements and the numbers of each element present. So hydrogen, we've seen in previous questions, has the symbol H. And according to this, there's 2 atoms of hydrogen. And the way we write that in a formula is to put a little 2 here. Carbon, we've also seen previously in this question, there's only 1 carbon. If you've only got 1 element present, you don't bother putting a number there, you just write the letter. And then 2 atoms of oxygen. Now we haven't previously seen oxygen, but the symbol for oxygen is a capital O, and as there are 2 of them, then we'd put a 2 there. Okay, so that's the formula given the information in the question, and that will get you that extra mark. Okay. Moving on to part C. The box contains the name of 3 compounds that are made from positive and negative ions. So we see the word ions here, and we're immediately thinking table of ions. So in the back of your exam paper, there will be a table of ions. You need to bear that in mind. And we've got lithium chloride, magnesium bromide, and calcium oxide. And so it's asking us to give the formula of the ions present in lithium chloride. So there's 2 separate words there. So that should make our life easy. if we find the table of ions, which is on the second to last page, we notice that lithium is this symbol here. And the other one that we need to find is chloride, okay, and chloride is here, okay. So all we need to do is copy carefully what we've been given as the symbols. So that would be Li plus and Cl minus, okay. Give the formula of magnesium bromide. This is a little more difficult, okay. To do this, we need to discover the ions for magnesium and the ions for bromide. Okay, so magnesium is this ion here. So if we just write down here, Mg2+, and if you remember when you're doing the formula, you need to think about it as a seesaw, as a balancing act. And then the bromide, so not bromide is here, that's Br minus. Okay, now Br minus has only got one negative charge on it, so consequently you would need two of them to balance the charge here, so 2+ and then 2-. And if we write that as a formula, then that would be Mg, no number because there's only one of them, when we combine it into a formula, Br2. Okay, so this formula represents this this balancing act in that diagram there. And that's the answer that we want in the question. So that's Mg Br2. Okay. Right, question 2 starts to look at the structure of an atom. So the diagram represents a lithium atom. Its nucleus contains protons and neutrons. So we've got a diagram here. So in the center, in the nucleus, so it might be wise to remind ourselves that this region of the diagram is called the nucleus, and that these dotted circles here represent electron shells. Okay, that might come in handy later. So we seem to have 3 protons, and we have 3 neutrons, and we have 3 electrons, okay, according to the diagram. Now the first part of the question, however, asks us about those 3 particles, and this is simply stuff you have to learn, okay. There'll be no clues for this necessarily. So a proton, so it starts with the letter P, which is handy because that reminds us that the proton is positive. If we use the same format as the negative down there, we'll put that little 1 on there. And then the neutron, okay, again, there's no clue really for this one. The neutron has a mass of 1. Okay, so neutrons and protons both weigh 1, and electrons weigh effectively 0. Okay, now having established that protons and neutrons weigh 1 each, this next question asks us to use the information in the diagram to give the mass number of this lithium atom. So if protons and neutrons weigh 1 each, and we've got 3 of each, okay, so that's 3 times 1 plus 3 times 1, which gives us a total mass of 6. Okay, which is important because you might have been tempted to look at the periodic table, which would have been reasonable. However, had you looked at the periodic table for the mass of lithium, you would have found that it's 7. Okay, so in this instance, this here is what's known as an isotope of lithium. It is lithium because it has 3 protons, but it's got a different mass because it's got a different number of neutrons. So it's an isotope of lithium, which may come in useful in a moment. Okay, so moving on. So the next part of this question, we're told that lithium reacts with oxygen. The word equation for this reaction is as follows. So lithium plus oxygen makes lithium oxide. So our first task is to give the metal, name of the metal in this equation. Now it's very likely that some of you might recognize the metal without any help, but in case you're struggling, once again, we can refer to our periodic table. But we do need to remember something about the periodic table. So on our periodic table, there is an invisible dividing line that goes there, 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 and so on. So it's a zigzag line that goes across the periodic table. Okay, and anything on this side of the periodic table is a metal, and anything on that side is a non-metal. So to cut a long story short, we'll find that lithium is way over here, so consequently is a metal. Okay, we'll go back to our question with the name of the metal. These 2, oxygen was on the other side of the line. So the metal is lithium. Okay, now for the next question, it asks us for a compound. Now a compound, as you need to remember, is a chemical that contains two or more different elements bonded together. Okay, so if it's got two or more different elements bonded together, its name might reflect that. So lithium oxide has got a lithium in it and oxygen in it, but it's one chemical, so that is the compound. These two are both individual elements. So the compound is a lithium oxide. And then a reactant in a chemical equation are the things that react. Okay, so these two chemicals here are reactants. So you could have either of those. And as we're on the topic, this here is the product. And again, you need to remember that. You need to learn that to recognize reactants and products. Reactants are on the left, products are on the right. So a reactant could be lithium or oxygen. You could have had any one of those two. So 2 out of 3 chance of getting that question right. Okay, lithium oxide contains the ions Li plus and O2 minus. Underline the formula of lithium oxide. So this is about turning the ions into a correct formula, both in terms of how many of the different atoms are in the formula and where you put the number. Okay, so the correct answer is this one here. Okay, so Li2O, because the number is always a subscript when we're talking about the formula. Okay, the only time we use a superscript is when we're talking about charge. Okay, so it's a subscript when we're talking about the number of atoms present. So we know we've got 2 lithiums and 1 oxygen. Okay, and to work that out, again, we could do with looking at our periodic table. Sorry, not the periodic table. We need to look at our table of ions, and we remind ourselves that lithium is Li plus, and oxide, the oxide ion, is O2 minus. So in order to work out the formula, you'll need 2 pluses to cancel out the 2 minus. So that would be Li plus again, and consequently that gives us our formula that we've already discussed, Li2O. Okay, so a little bit of work there for your 1 mark. Okay, so this next question is spotting trends, really. It's about group 6 elements. The group 6 elements are not ones that you need to know a great deal about. However, you do need to be able to spot trends in data. So we've got oxygen, sulfur, selenium, and tellurium. Our melting point here starts at minus 219, and it goes up to 115, up to 221, up to 450. A similar pattern happens in the boiling point, except the numbers are higher. And then with the density, it starts off very, very low, okay, and once again increases. And then we've got a comment on whether they're electrical conductors or not. Okay, so the first question says, describe the trend in melting points of the group 6 elements. So the melting points increase going down the group. Okay, so it's important that you make it clear going down the group. And then give the physical state of selenium and give a reason for your choice. So physical state, you've got a choice of 3 options really. You've got solid, liquid, or gas. Okay, so if we have a look at selenium, so at 400 degrees Celsius, 400 degrees Celsius is somewhere between these 2 values here. Okay, so we've got 221 and 685, so 400 lies between those 2. So at 221, selenium melts, which means, because it says melting point there, which means that it turns from a liquid into a, sorry, from a solid into a liquid. So solid into a liquid, and it doesn't boil until 685. Otherwise, it doesn't turn from a liquid into a gas until 685. So at 400 degrees Celsius, it must be a liquid because it's melted, but it's not hot enough yet to boil. Okay, so it's a liquid because 400 degrees Celsius is between the melting point, and the boiling point. Okay, so words to that effect would gain you that second mark. Okay, so there's two marks, one for the state of matter and one for the reason. Okay, so I'll just put that up on the screen there. Okay, moving on again. Explain why it is difficult to classify selenium as either a metal or a non-metal. Okay, so if we have a look at our table, right, so the biggest clue really is that selenium is a semiconductor. Okay, so metals we expect to be conductors and non-metals we expect to be non-conductors. Selenium is a semiconductor. Okay, so and just to confirm that idea, if once again we refer to our periodic table, we find that selenium is here. Okay, and that's reasonably close to that dividing line between the metals and the non-metals, and consequently all the elements down this border tend to have slightly different properties to those that we might expect. You see that silicon is here, and you may have heard of silicon as the main element found in semiconductors in computers, etc. Okay, so these elements down this dividing line have got semi-metal properties or metalloid properties. Okay, the next question tells us that selenium dioxide reacts with sodium hydroxide to produce sodium selenite and water. Okay, so your first impression of this question might be that we've never done any work with selenium. This doesn't matter because this is a sort of question where you're given information and then you're asked to actually interpret it. So we're given there the formula of all the chemicals involved. Okay, so we've got selenium dioxide, we've got sodium hydroxide, we've got sodium selenite and water. Okay, so they're all listed in order just so that you know what they are. And it asks us here to calculate the relative formula mass of sodium selenite, which is Na2SeO3, and you're given the masses actually in the question. Sometimes, or in the past maybe, they would have expected you to look up these masses in the periodic table. So if we are going to calculate the MR of this stuff here, and it might be wise to write out the formula and then work out the different masses that we need. So Na2 tells us that we've got two sodiums and one sodium weighs 23. Okay, so the Na would be 2 times 23, which equals 46. So the mass of sodium in this formula is 46. Selenium, there's no number next to selenium, so we know there's only one of them, and selenium weighs 79. And then the oxygen, okay, there are 3 oxygens, and 1 oxygen weighs 16. So 3 times 16 is 48. And then just to double check we get the right answer, it's best probably to use the calculator. So if we add those 3 numbers together, we've got 46, which is the mass of the 2 sodiums, plus 79, which is the mass of the selenium, and plus 48, which is the mass of the 3 oxygens. And that gives us a total mass of 173. And there are no units for this answer because it's a relative formula mass, and therefore we don't give it units. Okay, this next question deals with electron configurations or electron structure. Okay, so sometimes they're called structures and sometimes they're called configurations. It's the same thing, basically. And this is expecting you to understand the relationship between the electronic structure and the group and the period. Okay, so oxygen has got a structure of 2,6. It's in group 6. That's because the last number is the number of electrons in the outer shell, and that tells us the group number. And period 2, because there are 2 numbers in the configuration, and therefore 2 shells are in use, and that's period 2. So using that information, we might be able to work backwards and work out the configuration of chlorine. So the group number is the last number in the configuration, so that's a 7. And we know we're going to put 2 numbers before the 7 because that's the last number in the configuration. And then the reason we know we've got two numbers in front of it is because the period number tells us how many shells are occupied. And so there are three of them that are occupied. This is the last one, so the other two must be occupied. And these two shells must be full. So the first shell is full with 2 electrons in it, and the second shell is full with 8 electrons in it. Okay, so the configuration is 2, 8, 7. Another way of doing this would be to look up chlorine in the periodic table. You'll notice we're using this a lot. So chlorine has an atomic number. So down here is a key. So atomic number, and that, amongst other things, is the number of electrons in an atom. Okay, so the lower number is the number of electrons. In this instance, it's 17. So if we need to fill some shells with 17 electrons, then we first of all put them in the first shell, and the first shell, you need to remember, is full with 2 electrons in it. So we've still got 15 electrons left because we started with 17. We've placed 2 of them. The next shell is full with 8 electrons in it. Okay, and you just need to remember that. That's 10 so far of 17. So the final shell must contain 7. So 2, 8, 7. So that's another way of doing that question, getting the same answer. Okay, 2, 8, 7. Right, the next one. Given the electronic structure of a mystery element, okay, 285, you're also given its position in the periodic table. So either way, we can work out what it is. So if we use method 1, okay, if we add those 3 numbers together, that tells us how many electrons we've got. So 2, 8, and 5 is 15. And that's equivalent to the atomic number. We've just established that the atomic number is, amongst other things, the number of electrons. So if we know we've got 15 electrons, we could refer back to the periodic table and find the element with atomic number 15, which is phosphorus P. Okay, so there is phosphorus. And a second way of doing it is to use these numbers here. So we're looking for an element that's in group 5 and period 3. So group 5, easy to find. This is group 5, so it could be one of these down this group here. So nitrogen, phosphorus, arsenic, antimony, and bismuth. And then it's in period 3. Okay, now with the period numbers on this particular table, they're not numbered. It might be an idea to put them in just so that you know what you're talking about. Okay, so remember that period 1 is actually hydrogen and helium. So a lot of people might miss that out if you're not careful. Period 2, these elements here, but period 3 gives us phosphorus. Okay, so it's a bit like a coordinates on a map. So group 5, period 3 is phosphorus, which we've already identified here. Okay, and then the final question asks us about potassium. So its electronic structure is 281. So we'll notice that the 1 is the 1 there again. So 1 is the number of electrons in the outer shell. That's the group number. And the period number is the number of shells occupied. So in this instance, it's 1, 2, 3, 4. There are 4 shells being occupied for potassium. Therefore, it must be in period 4. If we just double check, okay, we've got potassium is here, right next to the period 4 number. Okay, so that is the right answer. Okay, moving along. Okay, so this question is about the reactions of potassium, which is one of the group 1 metals that we've studied. So in the middle, we've got the potassium, and then we've got 3 different chemicals that you can react potassium with. So you can burn it in oxygen, react it with chlorine, or react it with water. Okay, so the first question says, state one observation you would make when potassium reacts with water. So just in case you'd forgotten or I hadn't revised this, you'll notice that solution A and a hydrogen gas. Whenever you see a gas being made, you can be confident you're going to see fizzing. Okay, so there will be fizzing because of the gas. If you remember the reaction, you might also remember that you get a lilac flame because it gets so hot that it self-ignites. Okay, and anything else you would need, for example, an indicator for. So those 2 there are the main observations that you can make without the use of any other chemical present. And then apart from wearing gloves and safety goggles, which give one safety precaution that should be taken when adding potassium to water, so there's a few things we might want to consider. Right, so it's a small piece, okay, and we usually advise it's the size of a grain of rice. Okay, would be the size to add. You could use a safety screen to protect any observers. And you could step back, which sounds a bit simple, but it is very important that you step away from the experiment once you've added the potassium to the water. Okay. The next question asks us to look back at the diagram and give a formula for solution A. So solution A, there is no substitute here for learning a little bit about the potassium reactions of group 1 metals. So when you react potassium with water, they're not called the alkali metals for no reason, because solution A is going to be potassium hydroxide, okay, because when you react to the group 1 metals with water, you always get a hydroxide. So the formula of potassium hydroxide, if you weren't sure, you can work it out using the table of ions in the back. So I've just written that there so we know what we're looking for, but we're looking for a formula. So if we look at our table of ions, we'll discover the potassium is K plus, okay? So we put that on a little seesaw, okay? And the hydroxide ion is O minus. So again, we put that on the other side of the seesaw, and we notice that it's a single plus and a single negative, so they cancel each other out automatically. So consequently, the formula is simply KOH. Okay, so if we put that in the right page, so the formula is KOH. Okay, if you want to be pedantic, you can put an AQ there because it is a solution, right? So solution means dissolved in water, and AQ is the symbol for dissolved in water, aqueous. Right, suggest a value for the pH of solution A. Now I've already mentioned that solution A is an alkali, so you need to remember, possibly from your year 9 science, the pH scale goes from 0 to 14, okay, 7 is neutral, and then this way is more and more alkali, and this way is more and more acidic. Okay, so and potassium hydroxide is a strong alkali, so 14 would be a good answer, but anywhere between 12 and 14 would gain you the mark. Then it asks you to name a group 1 metal that is more reactive than potassium. Okay, so if we have a look at our periodic table, we need to remember that the group 1 metals become more reactive as you go down the group. Okay, and again, you need to remember that. And so any of these three would be acceptable, because there is potassium, rubidium, cesium, or francium would get you the mark there. They're all more reactive than potassium. Okay, so it does ask for a name rather than a formula, so you would have to put rubidium, cesium, or francium. Not that we ever see francium, but any of those would get you the mark for that question there. Okay, number 5. The following table gives information about some atoms A to E, and A to E are not the chemical symbols of the elements. Okay, so atom A, we're told, has 12 protons and 12 neutrons. Now, if we refer back to the previous question, okay, this one here, we can do a few bits and pieces. So, for example, protons and neutrons, they both weigh 1. So we can work out the mass if we need to. Okay, so we could put that in there. So the mass of this one would be 24, because protons and neutrons weigh 1 each. So if the atom has 12 of each, it must weigh 24. So that might be something that might be helpful to us as part of the question. It's just a way to think about what information you're being given and how it might be useful. This one, atom B, has 10 of each, so that would give it a mass of 20. This one is 6 and 8, which would give it a mass of 14. This is 11 and 12, which would give it a mass of 23. And this is 6 and 6, which would give it a mass of 12. Okay. Other things we might notice about this table, specifically the protons. Now, protons are important because protons define the identity of the atom. The number of protons tells us which atom it is. So, for example, if we've got 12 protons, we could look on the periodic table and we can find the atomic number. Okay, so atomic number is number of electrons. It's also number of protons. Okay, so it's both of those two things. In fact, it's primarily the number of protons. So if we find the element that has atomic number 12, it's magnesium. Okay, so that might be handy to us just to be able to identify the elements. But let's have a look at the question. So it says, give the letter A to E of the atom with a mass number of 12. Okay, so if we look down our little list that we've just identified, we'll notice that element E has a mass of 12. Okay, so that would be E. Then this one here, give the letter A to E of the atom found in group 1 of the periodic table. Okay, so we're looking for an element in group 1. So in order to identify that quickly, we could do the work out the electron configurations of each one, because the number of protons is also the number of electrons. Okay, so if we've got an element with 12 protons, it's also got 12 electrons. So its configuration is going to be 2, 8, 2, and the group number is the last number. Okay, so it's not that one. 10 electrons is simply 2 and 8. Okay, it's not that one. 6 electrons is 2, 4. Not that one. 11 electrons is 2, 8, 1. Okay, it is that one. All right, so D is a member of group 1 because it's 11 electrons going to the shells, 2 in the first, which is now full, 8 in the second, which is now full, leaving 1 in the outer shell, which means it's a group 1 element. Okay. Choose letters A to E of the atoms that are isotopes. Okay, give the reason for your choice. Now, earlier we talked about isotopes because this atom here is lithium due to the fact it's got 3 protons, but it's only got a mass of 6. Okay, and that mass of 6 differs from the mass on our periodic table, okay, for lithium, which is 7. So that means that it is that both of these atoms are lithium because they've got 3 electrons. This one, though, has only got a mass of 6, and the one in the table here has got a mass of 7. And that's what an isotope is. It's an element with the same number of protons that makes it that particular element, but a different number of neutrons. So in order to answer this question, we need to find 2 elements with the same number of protons. And it seems that C has got 6 and E has got 6. However, there's a different number of neutrons. Okay, so the answer would be C and E. Okay, and the reason is same number of protons, but different number of neutrons. Okay, and that's basically the definition of isotopes. They have the same element because they have the same number of protons, but they are different masses, and therefore we call them isotopes. Okay, next question. The diagram below shows the electronic structure of an element in the periodic table. Using X to represent an electron, draw a diagram to show the electronic structure of the element which lies directly below this one in the periodic table. So in order to do this, there's a couple of ways. One way would be to simply count the number of electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and identify which element it is on the periodic table. Okay, so the element with 10 electrons, in other words, an atomic number of 10 is neon. Okay, so that's neon there. Okay, so it's got 2 electrons in its first shell and 8 in the second. And the question asks us to draw a diagram of the element directly below, which is argon. And argon has got 18 electrons. Okay, so we go back to our question. We draw the first shell, which has got 2 electrons in it, and that's now full. You have to remember that. Then we could draw the second shell, which has got 8 electrons in it, just like it's the neighbour here. There's our 8 electrons, but we're drawing argon, which has got 18 electrons. Now that shell is now full, so we need to draw another shell. And we've drawn 10 already. We can draw another 8, which is handy because there's room for 8 in this shell. Okay, so that's the diagram we're after. Another way of doing this would be to remember that members of the same group have the same number of electrons in their outer shell. And so if this diagram is of an atom directly below that one, then we'd have to add an extra shell, then we'd have to put 8 electrons in it because there are 8 electrons there, and these two are in the same group because one is directly below the other in the periodic table. Okay, so there's a couple of ways of looking at that. Okay, number 6. So the diagrams below show the electronic structure of 5 elements, A, B, C, D, and E. The letters are not the symbols of the elements again. Okay, so there's a variety of different configurations. So this one is 2 in the first shell, 2 in the second. So we might want to write that as 2, 2, just to practice, and it might come in handy. This one has got 2 in the first shell and 6 in the second, so 2, 6. This one has got 2 in the first, 8 in the second, and 2 in the third. Okay, so you'll notice that that one and that one have got the same number of electrons in their outer shell. These two have got the same number of shells. Okay, so these two are in the same group. These two are in the same period. Okay, that's because there's 2 electrons in the outer shell of both of those, and that's what the group number is. And these have both got 2 shells occupied, which is the period number. This one is 2, 8, 8. And this final one is 2, 8, 1. Okay, so these two are in the same period, okay, because they've got the same number of electrons, same number of shells occupied. Right, so what do the questions ask us? Give the letters of elements found in period 2 of the periodic table. Okay, so period 2 is the second row. We've already established that these two here are in the period 2 because they have 2 shells in use. So the answer would be A and B. And the reason is they both have 2 shells occupied by electrons. Okay, I think we just have a quick look. So 2, 2, its atomic number is 4, and this atomic number here is 8, so 4 and 8. If we look at our periodic table and find the elements with atomic number 4, so atomic number 4 is this one here, beryllium, and indeed it is in period 2. And atomic number 8 is this one here, oxygen, which is also in the same row or the same period. So that should guarantee us the marks. And then the final question on this page here, give the letter of the element found in group 0 of the periodic table, give a reason for your choice. Now, as group 0, a special case, all the members of group 0 have a full outer shell. Group 0 is at the end of the periodic table, so they all have a full outer shell. So we're looking for an element that's got a full outer shell. Okay, so if we have a look at our configurations, 2, 2, that's not full because the second shell can hold up to 8. That's not full because the second shell can hold up to 8. That's not full because the third shell can hold up to 8. This one, however, does have a full outer shell because 8 is a full shell for the third shell. So the correct answer would be D. And the reason is it has a full outer shell. And just to be absolutely clear, you could quote that as 2, 8, 8. Okay, so So that's why it's a member of group 0, because it has a full outer shell. And then the final couple of questions here. Explain how the electronic structure of element E can be used to determine its atomic number. Okay, so element E has got the configuration 2A1. Okay, so 2 plus 8 plus 1 equals 11, right? And that is the atomic number of sodium. And this is because atoms contain equal numbers of protons and electrons. Okay, so the number of electrons is the same as the number of protons in an atom. Okay, so if we add the electrons together, we get 11. That gives us the atomic number. And if we look on that periodic table, then that is sodium. Okay, so sodium is here. Its atomic number is 11. Okay. And then the final question is, one of the diagrams represents the element oxygen. Oxygen reacts with potassium to form potassium oxide. Give the formula for potassium oxide and balance the equation for this reaction. Okay, so potassium oxide is going to contain some potassium and some oxygen. To get the formula, once again, we can refer to our table of ions. Okay, and we discover that potassium has a charge of 1 plus. Okay, so let's put the potassium here. And the oxide ion has a charge of 2 minus. Okay, so that's O2 minus. So for this seesaw to balance, we would need 2 potassiums to cancel out or balance the single O2 minus. So that would become K2O. Okay, because we need 2 of those to balance or cancel out one of those. And when we write the formula, we don't put the charges in, we just make sure that the charges have been balanced previously. So if we go back to our question, we can now put in K2O as our formula. And then in order for this to balance, we need to make sure we've got enough potassiums to make 2 K2s. So 2 K2s requires 4 potassiums altogether. Okay, so we put a 4 there, and that should balance it up because we've got 2 oxygens here and we've got 2 oxygens there. So that is balanced. Okay,